Hey there, my name is Sam. I'm a graphic designer, and today I'm going to be doing a mini deep dive on the magic of quantifying color. This is a topic that I find really interesting, and we're just going to skim the surface level, but this should give you a better idea of how we take things like colors, things that look like this. How do we take yellow or blue or green, and how do we quantify it and describe it so that when I want someone to know I'm describing this green, they know exactly how to locate that green on their screen? It's really, really cool. And it's really interesting because all of the ways to quantify colors are connected in some way. So today I'm going to show 4 different ways that we as graphic designers can quantify colors. There's RGB, Hex Codes, CMYK, and Pantone. Now, I am not going to be diving too deep into any one of these. I'm just going to be sort of doing like a brief overview. But if there are any one of these that you want to take a deeper dive into, go ahead and comment. Let me know if you want to learn more because I could talk about this all day. So we're going to start with RGB. RGB quite literally stands for red, green, and blue. So when we talk about RGB color, we are talking about red, green, blue. Now, RGB is a color model where we measure levels of red, green, and blue in a color, and it's very common for digital screens. Think your phone, your computer, your TV. The reason for that is because of pixels. RGB is common for digital displays because the color of pixels on most screens are red, green, and blue. Now, every single pixel has like subpixels that make up that pixel, and those can light up at different intensities to create different colors. So that's why we describe color in this way. It's just because the medium of where they're being reflected is through pixels. Now, the RGB range is going to range from 0 to 100% in intensity. So something can be like 100% red or 100% green or 100% blue. But the way that we represent that is by using a scale of numbers from 0 to 255. So there are 256 total levels for each color. So you could have like 0 red or 255 red, and 0 red would be 0% red, and 255 red would be 100% red. So the way that we write an RGB color looks like this. We type out RGB, and then we have a parentheses, and then we put the number for red. So what percent red is in that color? How much red is in there? It's going to be a number between 0 to 255. Then we write comma, and then we write the number for green, comma, the number for blue, and then end parentheses. So that's what the format looks like for writing RGB colors. So if I wanted to describe like pure red, like the reddest red you could possibly read, that is going to look like this on the color spectrum. And if we're writing that in RGB format, we're going to type RGB parentheses 255, comma 0, comma 0, and parentheses. That means there's nothing else in it. It is pure red, nothing else. But if we wanted to describe like this hot pink, that definitely has a lot of red in it. So it's still got 255 for that red value, but then it's also got some green and some blue in it, which makes sense because like pink is close to purple. So we're going to start to see some of the red have buddies like blue and green in there. So this is not like a pure color. If it was pure blue, it would be RGB 00255. Now, another thing that I think is really interesting is let's look at this green right here. This like shamrock green sits right here in the color spectrum. This one is written as RGB 72, 177, 135. So it's got a lot of green and it's also got a lot of blue in it. But if we look at a darker version, so we're just going to make a darker version of that color, notice how all of these numbers drop. So when the color is more intense, it's going to have a higher number green and a higher number blue. But then as it decreases and gets closer to like black, it's going to have lower numbers across the board. Okay, so now we're going to talk about hex codes, which is commonly known as the hexadecimal system. This is actually extremely connected to RGB. I find this connection just so cool. We're going to get into it. So I'm actually going to go back to RGB. So like, let's look at this color here, RGB. So I'm going to count how many characters are here, because if you're like a graphic designer and you have to reference this color in your work, think about how many letters and numbers you have to type. So it's 1, 2, 3, 4, 5, 6, 7, 8, counting the space, 9, 10, 11, 12, 13, 14, 15, 16, 17. That is 17 characters right there. That is a lot of characters to type out, which is why we have the hex code system. A hex code system is a way of writing colors or referencing color quantity. It's a way of referencing a specific color in a 7-digit method. Now, the first digit is a hashtag or £, and then there are 6 numbers and letters that follow it. This is really great when you're a designer because 7 total characters is a lot easier to write than 17. You're just cutting your work in half. It's also cutting your code in half, which is really, really helpful if you've dabbled in CSS or JavaScript and you're doing a lot of coding. It's really, really helpful to have a shorter way to describe colors. It just shorter code is a faster loading time. It helps across the board. So here's what I find so cool. When you're referencing a hex code is actually quite literally referencing the RGB version of the color because the first 2 digits of a hex code refer to the amount of red in a color. The second 2 refer to the amount of green, and the third 2 refer to the amount of blue. So this is just a different way to write RGB. Isn't that so cool? Okay, so why hexadecimal? Like, why go with hex codes? So decimal, if we look at that word, that literally means base 10. So that's a number system based around intervals of 10. Think like most currencies. We reference currency in like 10, 100, 1,000. That's a decimal system. But a hexadecimal system means base 16. That is a number system based around intervals of 16. Now, I'm really curious, can you guess why we're going to use a base 16 system for hex codes? Like, why would we use 16? That feels like such a random number, doesn't it? Well, it's not so random. For a hex code, we're basically converting the number from RGB to a shortened version. And if you remember, when we're doing RGB color codes, every RG and B level can range from 0 to 100% in intensity, and this is represented by a range of numbers from 0 to 255, which means there are 256 total levels for each color. Now, 256 is not divisible by 10, so we couldn't just use like a base 10 system because then there would be like remainders after the decimal point and it would get really complicated. We need something that 256 can be split evenly into. It's not 10, but it is 16. So that's where we get hexadecimal system, is because the total number of options for RGB is divisible by 16, and so that's how we do our conversion. It's really cool. The math is mathin'. Okay, so now here's where it gets even more complicated / fun / cool. The format of a hex code is so unique and so much fun. Now, there are only 10 possible numbers that we could use in each space here for a hex code. So we can use 0 through 9, which gives us 10 total possible numbers. But we need 16 possible figures or icons or something that we can put there. Like, we need 16 units that we can put in there, and we only have 10 numbers. That's why we bring in letters. So 0 translates to 0, and 1 translates to 1, and we do that all the way up through 9. 9 translates through 9. But then when we need to reference the number 10, we're out of numbers because we only have one little spot to put something there to represent that decimal. So that's where we switch over to letters. So 10 actually translates to A. 11 translates to B. 12 to C, and we go all the way to 15 represents letter F. So that's why hex codes have a mix of letters and numbers, and that's why you're never going to see a hex code have any other letters besides A through F. So you're not going to see like a G or a K or a Z in a hex code. Those have no point. They're not needed. They will not give you a valid hex code because of the hexadecimal system. Okay, now I'm going to show you the actual formula for creating a hex code. And this is not something that you should feel like you have to remember or that you will ever use in your work, even if you're a full-time graphic designer. I've been doing this for years. I only came across this formula when I was doing research for this presentation. I think that this is so cool, and it makes me appreciate hex codes and color even more. And I'm just showing it to you because I genuinely think it's so fun. So try not to get overwhelmed because there's going to be a lot of numbers on your screen, but I'm going to make it as fun as I can. So essentially, for a hex code, remember the first 2 digits represent the amount of red in a color, The second two represent how much green is in a color, and the third two represent how much blue is in a color. Now we treat each one of these numbers individually, or each one of these characters, I should say, individually. So they're not like a total, like we're not coming up with a number like 24. We're coming up with like, okay, this one means 2 and this one means 4. And so that's how we represent the red. Here's the formula for each one. And what we do is we first find what this character translates to, and then we find what this character translates to. So I'm going to show you what to do for a real life example. So we are going to translate RGB 184, 52, 224. So 184 is how much red is in the color. 52 is how much green is in the color. 224 is how much blue is in the color. And you can sort of maybe start to picture like what this color looks like if you kind of can do a little color math in your head. But anyway, so the way we do this formula is first we want to find the first digit of the hex code. So like we do hashtag and then that first digit, what comes there? Well, to do that, we take the first number, 184, and we divide it by 16. And that gives us a number. In this case, it's 11.5. So 11 is our first digit because we take anything that comes before the decimal and that's our first digit. So if this was like 11.9, we would still consider it 11. So 11 translates to B in the hexadecimal system because remember anything after 10 we have to translate to a letter. So 11 is B. There are the loudest birds in the world right outside my window. I don't know if you can hear them, but they're so loud. They're really into this color stuff. Okay, so our first digit in our hex code is going to be B. And then we take the remainder, meaning, I'm going to go back, whatever remained after the decimal here, so in this case it was 5 or 0.5, we take that remainder and we multiply it by 16, and that translates to 8. So that tells us that our second digit in this hex code is going to be 8. So the hex code version of a red for this color is B8. Isn't that cool? Okay, now we're going to do green, and this one I'm going to do a little faster. So we're going to take 52, we're going to divide it by 16, and that gives us 3.25. So our first digit is 3, and then we take the remainder, that 0.25, we multiply that by 16, and we get 4. So our second digit is 4. So for our hex code, we've got B8 represents how much red is in a color, and 34 represents how much green is in a color. All we have to do is find the blue. So we're going to take 224, divide it by 16, which gives us 14, which is an even number. Awesome. So we know that 14 translates to E, so that's the first digit for blue. Now, this one's a little unique because there's no remainder, and when there's no remainder, we can't divide it or multiply it by anything. If we were to multiply 0 by 16, we're still going to get 0. So the second digit is 0. So the full hex code is B834E0, and here's what that color looks like, which makes a total sense because it's super bright, it's got a good amount of red, and it's got a good amount of blue, but a little bit more blue, so it's going to skew a little bit more towards like a purpley blue color. Isn't that so cool? I love that math. Honestly, I think it's just such a fun activity to translate RGB to hex codes. Maybe it's like the math kid in me, but I love it. Okay, thank you for bearing with me. So now we're going to talk about CMYK. CMYK stands for cyan, magenta, yellow, and key, or key usually means black. Usually it always means black, but we use the word K, or we use the letter K and the word key. CMYK refers to the 4 ink plates used in color printing. So CMYK is almost always what we're going to use when we talk about printing color. And the format that we use to describe CMYK is we type out CMYK, and then we do a parentheses, and then we put the % of each color, and we follow the same order. So whatever number goes here represents how much cyan is in a color. And then whatever number goes here is how much magenta, whatever goes here is how much yellow, and whatever here is how much black. Now there are a lot of digits in here. Like if each one of these is a 2-digit number, like 99, then that is going to give us a pretty long code, which is why you can see we tend not to use it in digital formats because it's kind of a long way to describe color. CMYK, if we wanted to translate the shamrock green into CMYK, that's what it looks like. We've got 59% cyan, no magenta, 24% yellow, and 31% key or black. If we were to describe this color, this one's going to be a little bit brighter of a color, and it's going to have more cyan and more yellow. I think more yellow. Yeah, a little bit more yellow. but no black. Do you see how this one has 31% black? You wouldn't really call this like a dark color, but compared to this one, it's a lot darker because this one has absolutely no black in it. It is a pure, bright, saturated color. Okay, and then finally, we're going to talk about Pantone. Pantone, I like to describe as its own thing. Pantone it's doing its own thing. The reason that we have Pantone is because, or the reason that Pantone exists, I should say, we don't have Pantone, they exist whether we want them to or not, or need them. Screens are unpredictable. It is very hard to know exactly what color someone is talking about when it comes to printing products and packaging. So if I say yellow, you don't really know what yellow I'm talking about. Or if I'm referencing a certain hex code on my screen, your screen just might look a little bit different. So it might be hard for you to understand exactly what I mean. Pantone colors are an industry standard color matching system, and they're used for accurate color reproduction. So Pantone was really smart, and they saw a massive need in the market for there to be a universal color matching system. So that's what Pantone is. The colors for Pantone change based on how something is printed and what kind of material it's printed on. So they could take the exact same ink and put it on a different type of paper, like uncoated paper or coated paper, and it's going to change how it looks. And so Pantone says, these are the types of paper, these are the types of materials, here's how something is printed, here's the color we're talking about. So that way, if you're printing something and you're like, oh, I thought I was getting Pantone yellow, it's gonna look way different on uncoated paper than it is maybe over here on coated paper. These are two super different colors. And if you're like, I don't know, Lay's potato chips or something, and you're printing millions and millions of a product, you want to make sure everything matches, especially if you're having things printed at different factories and you don't have someone there to like actually compare colors. Pantone really helps save the day there. Okay, I know that some of this stuff felt really deep and nerdy and some of it was just like surface level, but I just so enjoy this topic and I hope that you had fun learning a little bit more about color. I think that color is so magical. The way we quantify color is just even more fun. And if you want a fun challenge, I would totally recommend that you find a random RGB color, just like a random color, and you use that math to see if you can correctly identify the hex code for that color. It should take you a couple minutes, but it's just such a treat, and it's so cool to know that you can do it. You never have to do it, but it's really cool to know that you can. All right, I hope you enjoyed this video. If you have any questions or if there are any other topics that you want me to take a deep dive into, go ahead and comment below. Thanks.